Hi guys, we are speaking from National Research Nuclear University from Moscow. This is presentation by the name of Knowledge Representation Models in Cognitive Search Support Tools. We are focusing on knowledge management. The general problem is transfer of existing knowledge into the information environment. And the new knowledge synthesis is based on the search, analysis and transformation of existing knowledge. Any new knowledge is based on existing one. We consider cognitive process as a system in terms of general system theory. The scheme of a cognitive process is similar to scientific search process and includes following stages: searching and extracting of information blocks, combining validation of these blocks, building the system of concepts corresponding to their criteria, and presentation of the new personal knowledge from these blocks and concepts. Knowledge can be represented as a semiotic triangle with a connotate. This allows us to take value into account and link to the context of use. We define ontology as a set of three interconnected systems by the general systems theory. That includes the functional system, the system of concepts, and the terminology system. In these terms, we define cognition as a searching path on a network of meanings from a fact problem to a fact result. In this way, cognitive documentary information search is a search for a path on an ontology multigraph, from the vertex of the original concept to the vertex of the target result. As an ontology data model, we use oriented graph that has properties of a meta, hyper, and multigraph. We use main operations on ontologies that allow solving information retrieval tasks, like operation of union, operation of intersection, ontology scaling, and aspect projection. The construction of aspect projection allows us to consider the content of any document in some context. We define the aspect by the functional system like this, where the main basic subjects are supporting of concepts and functional relationships that are the characteristics of this aspect. We built a graph using our automated tools, so this is our screenshots. On the left picture, this is the ontology graph built on full text document, and the right one presents the results of aspect projection. To build such a graphs, we used automated methods of text processing, and for its ontology presentation we followed the steps: tokenization, preprocessing, text preprocessing, and identifying of semantic units like concepts, properties, nominal groups, etc. In the automated methods of text processing, we used our own classification of relationships. This is our classification of relationships. So in this table, columns and rows presents their properties. Using previous table, we get a taxonomy relationships like this. So here is relation type, its meaning and feature. By the results of text processing, we get triplets, that is a pair of concepts and linguistic construction in between. we analyze linguistic constructs and build patterns. So here is the fragment of taxonomy of relationships, where the pattern for categorization corresponds to the class for Russian case. Here are examples of relationships categorization in triplets for Russian case. And this is the results of our experimental study. So 82% of triplets were correctly identified. Almost 5% of triplets were not categorized due to the lack of vocabulary. And 13% of triplets were categorized incorrectly. For information retrieval tasks, we use basic taxonomies and quasi-thesaurus. That means automatically build thesaurus on documents collections. On this table are the stages of cognitive process and operations of cognitive search and how they relate. So this is our developed by us information retrieval system, which includes cognitive subject tree, thesauri, categories, taxonomies, contains advanced document searching tool, and supports verbal and clustered and graph searching technologies. In this presentation we showed our work. We developed automated method of creating and extracting triplets from full texts and building ontology graphs with their advanced working tools. For all the details of our advanced work, please follow these science papers. Thank you for having me. Bye.